Hello, hello, ladies and gentlemen. Thank you for joining me as we finish off our 2017 Grade 8 Gauss. We're on the last question, question 25. Brady is stacking 600 plates in a single stack. I feel like that might topple over. Okay. Each plate is colored black, gold, or red. Any black plates are always stacked below any gold plates, which are always stacked below any red plates. So it's black on the bottom, then gold, then red. Okay. So some plates, maybe some other plates, some more plates. The total number of black plates is always a multiple of 2. The total number of gold plates, the middle ones, always a multiple of 3. And the total number of red plates is always a multiple of 6. For example, the plates could be stacked with 180 black plates below 300 gold plates below 120 red plates, or 450 black plates below 150 red plates. There are no gold plates at all. So there's no guarantee that you have any particular colored plate. Or we could even just have 600 gold plates, no blacks or reds, period. In how many different ways could Brady stack the plates? Okay. So the colors are nice, and the fact that the blacks are all below the golds, all below the reds, means I don't have to worry about position and sort of, well, you know, you could have some reds and then some golds and then some reds. What we really just need to count are, okay, how many reds have I got? How many golds well, not me. How many golds has Brady got? How many blacks has Brady got? Because once I know those numbers, all the reds are on top. All the golds are after, and all the blacks are on the bottom there. So there's no real thought about the stack. Stacks of plates really just comes down to how many reds, how many golds, how many blacks. And when we make that connection, the counting becomes a little easier. Okay? Now let's look at the other conditions. So the black plate's always a multiple of 2, gold plate's a multiple of 3, and red plate's a multiple of 6. Now we know the total is 600. It says it right here at the start of the question. Now 600 is, well, it's a multiple of 6. It's 6 times 100. Now 6 is a multiple of 2, and 2 is a multiple of 2. So if we think about this, we might say something like, let 2r be the number of, wait, is it, no, it'd be 6r. So 2b for black. My mistake. So that's the number of black plates. We have a multiple of 3 number of gold plates. And we have a multiple of 6 number of red plates. So I do 2 times an integer, 3 times an integer, and 6 times an integer to satisfy the needing to have a multiple of 6 for the number of red plates. But what do we know? Well, 600 is 2b plus 3g plus 6r. Okay, well, the thing that catches my eye right away, bring the 2b and the 6r over to the other side. Well, what do we have over here? An even number. So what must we have over here? This must be an even number. So it's not enough just to say you have a multiple of 3 number of gold, because you can't do a stack that has 9 gold plates. Because then you'll have an even number of blacks, an even number of reds, even plus 9, which is odd. That doesn't equal an even number like 600. So 2 divides 3 times g. It must be even. That's what it means to be even, is that 2 divides the number. But 2 is a very special number. It's prime. And prime numbers, if you have a prime and it divides a product, then the prime divides, so if a prime divides a times b, then either the prime divides a or the prime divides b, or both. So either 2 divides 3, which is impossible, or 2 divides the number of gold plates. So I'm going to create a new letter, capital G. So little g is just 2 times capital G. And we can do something similar. 2b, 3 little g. I'll bring the capital G back in a moment. But we can do something similar with our multiples of 3. Okay, 3 divides 600, 3 divides 3G, 3 divides 6R. So 3 divides 2B, and as a result, 3 will divide B, because 3 can't divide 2, but 3 is prime, so it has to divide one of 2 or B. So we could do something else. We could say let B equal 3 times some capital B. B has to be a multiple of 3, so why don't we say it's 3 times capital B, and I'm also going to let R just be capital R. Okay? So then what have I got? Well, the number of gold plates is 6 times this capital G, and the number of black comes first. So let me. The number of black plates is 6 times capital B. Okay? The number of gold plates is 6 times capital G, and the number of red plates is 6 times capital R, which that didn't really change. I'm just making it capital to compete to look similar to the others. So they were kind of sneaky in the question. They said it was an even number of black plates, but turns out it's also just a multiple of 6. But that was sort of hidden and we had to explore. And now that I've got 600 is equal 6 times something plus 6 times something plus 6 times something, we can divide by 6, and then the real counting will begin. So 100 is going to be B plus G plus R. Now these are not the numbers of plates, but these are just integers. So I need to find the number of ways that I can choose an integer B, an integer G, and an integer R, so that they all add up to 100. Okay. So what are we going to do? Well, we need to find a way to count this stuff systematically. It's no use sort of guessing, checking, and saying, well, what if I had 50 and 38 and 12? Oh, that works, and maybe a 77 here, and a 13 here, and a 10 here. Or maybe 0, 0, and 100. I mean, yes, we're starting to get different possibilities. And so I know the answer is at least 3 now. But I'm not doing this in a methodical way. And this is something I stress when we do counting problems, or whenever I do counting problems in these videos, is we have to do it in a very exact, very precise way. So, there's nothing that's leading me in any one particular direction. I'm going to focus on the black plates. Okay? Now, at most, the black plates there could be 100 of them. I'm going to start to make a little chart. So at most, the black plates, there could be 100 of them. Well, sorry, not 100. I'm falling into my own trap. At most, B could be 100. And what would this mean? That would mean that there are 6 times B black plates. So there'd be 600 black plates. So at most, capital B could be 100. Okay, so what's left over? Well, G and R here are left over. 100 minus B, that's 0. So G and R need to add to 0. So what could I have for G and for R? Well, I guess they both have to be 0. There are no gold plates, no red plates at all. Just because 6 times 0 is still 0. So that's one way. What if B were 99? Well, what would be left over for G plus R? Well, it'd be 100 minus 99, so it'd be 1. So we could have 1 G and 0 R's, or 0 G's and 1 R. And that's 2 ways. Or capital B could be 98. We keep doing this until we notice a pattern or until we think, well, I'm not seeing anything, let's try something new. But we get 3 different ones there. So 1, 2, 3. If we do another one, 97, what's left? These numbers, G and R could add up to 3. And so we could have 3G, and that would be 18 gold plates and 0 red. 2 and 1, 1 and 2, 0 and 3. And that's 4, although it's crammed down in the bottom, so I do apologize to low resolution viewers. But in general, what's happening? Well, I pick a B. G and R need to add, G and R need to add up to what's left. And so we could have the G be all of that, and the R be none of it. Or we can slowly take from the golds and add to the reds. And then eventually, oops, wrong side there. Eventually, we just sort of run through all the possibilities. So if if G plus R is 4, we could have 4 and 0, 3 and 1, 2 and 2, 1 and 3, 0 and 4. And how many is that? Well, that's 5. How does that relate to my 4? Well, it's one more. Because what are we doing? We're counting 0, 1, 2, all the way up to whatever was left over, 100 minus B. So how much is this? Well, there's going to be 100 minus B of them plus one more. So 101 minus B. So for each B value, I get 101 minus B ways to pick the number of black plates, gold plates, and red plates. Okay? So what have we got? Well, we sort of started off, if B is... So choose our B and then number of ways to stack. Because we don't actually need the G or the R anymore. So we could have 100 B, and so that would be 600 black plates. And so that would be 101 minus 100, one way to stack. And then with 99, we had 2 ways to stack. With 98, there were 3, 4, 5. And then at the end, what's it going to sort of look like? Well, there'll be 1B, and so then we'll have 101 minus 1. 100 ways to choose the number of gold plates and the number of red plates. Or we could have no black plates at all. And there'd be 101 ways to choose the number of gold plates, the number of red plates. And if you're a little wary about our reasoning back here, with all this, skip to the end and try, are there really going to be 101 ways? So imagine what the G and the R columns would look like. Well, we'd start with, maybe there's 100 for the G and 0 for the R. 99 and 1, 98 and 2. All the way down to 100 and 0, 99 and 1, 2 and 98. 0, 1, 2, 3, 4. So there's going to be 100 of those plus one more. So yeah, it is 101. Okay. So the number of ways to stack is just going to be 1 plus 2 plus 3. Each different B value gave us more ways to stack. Okay. And if you wanted to, I suppose you could break out your calculator, and it doesn't take that long to add it up. I think it's a little over 5 minutes, because I used to give a talk that proves the formula for adding up so many numbers in a row. And I used to get someone to try doing it on their calculator in the same time, and I would usually finish the talk before they did. Or if they finished before me, they usually had an error. But you can, if you got the right amount of time, you can do 1 plus 2 plus 3 plus 4 plus 5. Just make sure your finger doesn't slip and you'll be fine. But if you'd like a faster, more accurate way to add up a certain number of numbers, and you haven't seen this formula before, it's a good formula. But 1 plus 2 plus 3 up to, and you can cut it off wherever you want. So I usually say up to n, adding the first n numbers, so adding the first 5 numbers, the first 10 numbers, and things like that. There's a very nice formula for this. N times n plus 1 all over 2, and this always works. You'll always get an integer. So if you don't know this formula, it is a very good one to have. I find it comes up every once in a while on these contests. Very important to know. So how would that help us for this? Well, we want to add up first 101 numbers. So the number of ways to stack is equal to 101 times 102, all divided by 2. And again, I'm not going to grab my calculator because 102 divided by 2 is just 51. 51 times 101 is 5151. So I think all the numbers presented were in the 5,000s. There we go. E. So our answer is going to be E. And I'm sure if you grabbed your calculator, you would get 5151 as well. But note that the formula is just so much nicer, so much neater, so much faster. Very, very excellent formula. And I really liked that question. I thought it was a good question. Nice way to sort of end the paper. So that was the 2017 grade 8 Gauss. I guess the next one will end up being the 2018, so you can look for that around my channel if and when it's posted. If you're looking for easier Gausses, you can take a look at the grade 7. If you're looking for more grade 8, I have tons of grade 8 Gausses. And if you think you're ready to try something a little harder, I would encourage you to take a look at the Pascal. That's the grade 9 multiple choice contest, but possibly even the Friar, because the Friar paper is also aimed at grade 9, a little harder than grade 8, but it requires written solutions, and so slightly different approach, and you actually have to show your work and explain what you're doing. It's a worthy challenge and something you might be interested in looking into. Okay? But with that in mind, we finished our paper. It was a good paper, and I will see you for more math in the next video. Until then, take care and have a wonderful day.